Okay, in this tutorial we're going to go over the mechanics of ventilation, okay, the first physiology lecture, and we'll start off with a recap on last tutorial. So this red line here and here represents the diaphragm, and when you breathe out, the diaphragm relaxes, which causes basically all of the abdominal cavity to shift up, and that pushes all of the air out of your lung, because there is a decrease in volume within the thoracic cavity. So that's a decrease in volume, which means it pushes the air out, and then when the diaphragm contracts, it comes down, and that pulls the lung with it, which will pull in air. Now if we were to represent that on a graph, so if we start with no volume in our lung, and we start to increase, so we're breathing in, the volume of air coming into our lung increases. That's why there's an increase in this graph. Then, when you want to get all the air out of your lung, you expire, and that pushes the air out. So there's a decrease in volume. So you can say inhale, increase in air, exhale, decrease in air, aka the amount of volume within the lung. Now that we have the volumes out of the way, we can go to the pressure. And pressure is important because it's what drives all of this function. So if you were to imagine you're in a plane and they were to open up the door like in the movie, all of the air gets sucked out because it's so low pressure outside and high pressure inside. So that pressure difference is what causes this airflow to occur. It's going from high pressure to low pressure. So let's use those principles in the lung. In the orange here, we can see that there's a lung, and this little gauge here represents the amount of pressure in the lung. Now, if we were to look on the graph here, when you breathe in, you increase the amount of volume within your lungs. And the equation for pressure is pressure equals force over area. Now, when you inhale, you increase the area in your lung, because you can see this lung is much bigger than this lung. So when you increase the area, you decrease the pressure. That's why when you breathe in, there's a decrease in pressure, because there is less of a force being exerted because there's more of an area. Then at a certain point, it goes back up, because when you breathe in, you kind of get to the stopping point and there's no air flowing, and that's because there's nothing driving it, there's no change in volume anymore. So that would be around the same point up here. No change in volume, so it equalizes. Now for the opposite, when you're trying to push air out, you need to create a high pressure system. Like in the airplane, when there's heaps of air within the plane, that's high pressure. So when you open that door, heaps of the pressure comes out. That's why when you exhale, there is an increase in pressure, because if you imagine all the air particles are getting jammed together, and that increases the pressure. So if you imagine an increase in force because of all of these air particles getting squished together, increase force, increase pressure. Then, like during inspiration, it comes back down to zero. And that's because there's no change in pressure anymore. Once you breathe out, there's a point where no air moves, and that's when it comes back down to zero, because there's no change in pressure. Now that we have this basic graph on what's happening within the lung, we can see what's causing that. Because the lung basically doesn't have anything within itself that causes it to increase and decrease, it's all this diaphragm and the chest wall. We know that this chest wall pressure is what's causing the lung to change. Because if we imagine the analogy of our hands being the pleura, when one moves, it brings the other with it, and one's attached to the lung. So if you were to imagine this was the diaphragm and this was the lung, when you pull that down, it pulls the lung down with it. So this parietal pressure is really important. We can also imagine that as the plane, because we know that this parietal, this pressure within this pleural cavity has to be negative, because negative means that it's sucking the two parietal and visceral membranes together. So if there was no negative pressure, one would just be able to fall away, and your lung would shrivel up, and you wouldn't be able to breathe, basically, because it wouldn't change in volume because it's not attached to anything. So if we know that, we can start here. We start at negative because we know that it needs to be negative to have these two walls stuck together. So if it starts negative, when we inhale, we have to decrease that pressure. And that's because we need more of a force pulling it out. So if you have a decrease in pressure, it pulls it more. And if you're like trying to pull two particles away from each other, that means that there's less pressure because there's less force within that little bit of area. So if we end it there, we'll just say the pressure becomes more negative. And that's an important point that he keeps hammering on. This pleural pressure becomes more negative. It doesn't become negative because it's already negative. Whereas this pressure within the lung becomes negative because it starts at 0 and it becomes negative and then becomes positive. But this becomes more negative, and then when you exhale, it becomes less negative and goes back to normal. Well, the shape's more like that. So it goes negative to suck the wall out, then less negative when it's pushing the wall back in because all these particles can come back together, and that's a bit more force in that little bit of area. So if you get confused about pressures and everything, try relate it back to this formula because it's basically area. If you relate the area of both the membrane or within the lung, it helps to imagine why there's this change in pressure. Okay, now we'll do a quick recap on everything. Your lung changes in volume when you breathe in and out, and that allows air to come in and out of the lungs. So when you breathe out, air goes out. When you breathe in, air comes in. So when air comes in, the volume within your lung increases. When air goes out, the volume in your lung decreases. Now with this volume loop, this is detecting the amount of pressure within the lung and within the pleural cavity. The lung becomes negative, but then it returns back to this equilibrium because when you breathe, there's always a pause, and this pause is when it's at 0 because there's no change in pressure. That means there's no change in volume. So negative and then positive for the expiration because you're squeezing all the air together and that's creating high pressure. And then with your pleural pressure, aka the pressure between these two pleura, the parietal and the visceral, it has to stay negative so that they're stuck together. If it wasn't negative, they'd just flop around, they wouldn't touch, but negative in order to keep them together. That's why it starts at negative and then becomes more negative, because if you're imagining it's pulling down, so it's increasing the amount of volume within this pleural cavity, which we know increase area, decrease pressure. So decrease in pressure, and then like on this side, there is an increase in pressure, in the pressure, so it becomes less negative, more negative, less negative. And this one doesn't have the same shape as that one because when you're breathing out, this chest volume stays the same. It's constantly having to have that negative pressure to hold it out. Whereas this lung, it's just the air within the airways. So it's so at a certain point, the air comes in the air and it just airways and just sits there. But up here, there's more of a roll to keep it open. So that's why this one has down then up. This one has an S curve because it goes down, but then it comes back to normal, goes up, goes back to normal. So that's the basics of ventilation. In the next one, we'll go over the respiratory cycle, which is basically a graph on what is happening within the airway and the change in volumes.